This is Tony Chang. He's from Google. He's going to be talking about Google Chrome, and more specifically, I think the Linux version of it. He's been working on that for a little while, and it's actually, there's a dev channel that you can download it for Linux right now and try it out, but only if you want to. Here you go.
Hello. Hi, I'm Tony. I work on Google Chrome. I've been working on it for about 2.5 years. Initially, well, so to give a little bit of background, in case you're not familiar with Chrome, it's a web browser made by Google. And it tries to do a couple things differently from other existing web browsers like Internet Explorer, Firefox, or Safari. One of the key differentiating factors with Google Chrome is that it uses multiple processes. And it uses multiple processes to render web pages. However, we didn't build the whole thing from scratch. Building a whole web browser from scratch is actually a huge amount of work. And rather than doing that, we leveraged an open source project called WebKit. WebKit is basically the part of a web browser that takes the HTML and generates the web page on the screen. WebKit is a project that's currently run by Apple, and its most common use is in Apple's web browser, Safari. But it's actually just a generic library that you can use in any application. WebKit itself just takes HTML and WebKit itself takes HTML and generates something on the screen, and it's often embedded in other applications. Apple uses it in a lot of products like Dashboard. All the dashboard widgets use WebKit. In their mail product, if you receive HTML email, it's rendered using WebKit. And it has a lot of nice properties, namely that it's fast. And so Google decided to use it as well when building its web browser. So what makes it different than, say, Safari, which also uses the same rendering engine for generating HTML pages? Well, we tried to take advantage of the fact that everybody's probably experienced this, where you're browsing the web and all of a sudden your browser crashes. And maybe the culprit is bad interaction with Flash, or maybe the culprit is just a bug in the browser, in the rendering layer, or maybe it's a bug in image decoding. It's quite common that, like, taking PNG graphics and decoding them, it's actually a tricky process, and there are bugs in it. And if there's a bad bug in it, it can bring down your whole browser. In Chrome, we try to avoid that by running each tab in a separate process. And one of the benefits is, in that case, if there is a bug in WebKit that causes a program to crash, or causes WebKit to crash, we can actually keep the browser running. And all your other processes are... Oh, all right. As I was saying, if WebKit crashes, we can keep the browser running. You can actually demo this in any existing build of Chrome. If you navigate to the URL about crash, there's, I think, a divide by 0 in the code. If you type in about crash, we do a divide by 0 in a WebKit process, and it crashes the process. And as you can see, the browser itself still runs, and my presentation is still there. Feel free to ask questions at any time. I'm trying to give some background. Some of this is already available in, like, public talks and descriptions of Chrome. I'm going to go in a little bit more detail in a second. So I'm going to talk about the different processes the browser uses. Google Chrome runs approximately 1 plus n processes, where n is the number of tabs you have running. The extra one process is the browser process. And this is the one that actually manages all the tabs. It manages all the other processes, and it makes sure, and it does some administrative work that happens outside of rendering web pages. So this includes all aspects of the UI, and it includes some state that you want to keep across page loads. So like your history. It also includes the network stack, so it also includes downloading images in HTML, and so forth. This is commonly referred to as the browser's Chrome. Chrome refers to everything in the browser around the actual content. So all of this area, the URL bar, the frame that resizes, that's all considered the browser Chrome. And that runs in a separate process. This process, if it crashes, you actually lose everything. There's no way to avoid that. If it goes down, then since it manages all the tabs, if you lose the browser process, you've lost everything. And so we try really hard not to have bugs in that code, but there are still crashes. The renderer process is what each tab runs. Each tab runs a renderer process, and it's basically just responsible for rendering HTML onto the screen. It also decodes images, because that's part of the process of displaying something on the screen. So this presentation, for example, is just HTML. There's nothing special about it. And so it's being run in a separate process. We actually allow, we added this to the browser, a task manager, so you can see the other processes, that Chrome is running. Anybody can view it. If you look, if you hit Shift Escape, or if you look in the menu in the title bar, you can see what processes Chrome is currently running. So I only have one tab open, and so that's this one. This is a renderer process. And then I have the one process, which is my browser process, that runs everything. If I were to open another tab, say I load Google, it shows up, and now I have two tab processes, one for my presentation and one for Google. And they're completely isolated, and you can even, if you want to kill a process, you can do that, and it'll kill the process, and the other process will keep going. Kind of tricky. It's not entirely true that every tab runs in its own process. We try to. We try to do it as often as possible. But there are some cases where, to maintain web compatibility, we can't do that. So in general, we run a new tab in its own process, and like every time you navigate to a new page. So for example, I'm on Google. That's running in a process. If I were then to navigate to, say, Yahoo, it still shows three processes, and an extra process. It still shows three processes, one for Yahoo as well, except when I navigated from google.com to yahoo.com, it actually killed the old process and spun up a new process to load yahoo.com. We do this for a variety of reasons. One of the benefits is it lets you reclaim all the memory you used to be using. So if google.com was using a lot of memory, or suppose it were something like Gmail, which uses lots of memory, when you navigate from Gmail to another page in the same tab, we go ahead and kill the Gmail process and just spin up a new one. And it's convenient because it lets the operating system reuse all the memory that Gmail was using. There are some cases where, for web compatibility, we can't always do that. For example, it's possible to have pages that are connected to each other. And I will give an example of that. Okay. So this tab is running in a process. Let me do it this way. Okay, so now I have 3 processes. I have my main browser process, and I have 2 tabs, one for my presentation and one for this example. If I click on this link, it opens a 3rd tab, and I can drag it out. So now I have 2 web pages. The bottom 2 tabs are actually sharing a tab process. They're sharing a renderer process. We show that in the task manager by not putting a separate memory or CPU usage, because it's going to be the same as the one above it. They're sharing the same process, so they have the same. They're sharing memory and CPU usage. You can only measure it for the 2 together. The reason we do this when you open a link off of a page is because it's possible for 2 web pages to communicate to each other. You can do this via JavaScript. When you open a new page, from the second page, I can communicate back to the first web page and run arbitrary JavaScript. It works because JavaScript exposes like a window.opener property, and then through the opener property, you can talk to the window that opened you. This is important. You can see it also in this example. You can tell that they're running the same process because this animation is running in the second process. But if I run JavaScript back in the first tab, the animation stops because the 2 tabs are sharing a process, and they're sharing the same JavaScript context. And because of that, if JavaScript has to stop on the one tab, it has to stop on the other one because they're the same context. Does that make sense? I can also demonstrate, I can force the second tab into its own process by just opening it in a new window. So now the 2 tabs are using separate processes. I didn't follow the link, so they have no communication with each other. JavaScript only lets you communicate when one window opens another one. In this case, I opened it myself, and so it has no idea. This second page has no idea about the first page. And so when I press the button to change the parent background color, it can't do it because there's no parent. I just opened it on its own. And likewise, as the animation is running, if I run JavaScript in the first tab, it's not going to stop the animation in the second tab because they're running in completely separate processes, and they're not related to each other at all. And if I were to then kill one process, it's not going to affect the other one. When they were connected, if one of the pages went down, they would both go down together because they're sharing the same process. And let's jump back to the presentation. Questions so far? Everybody got that? So how does this actually work? In a traditional browser, this is basically how you'd go about loading a web page. Even in, say, Safari, you still have a differentiation between the part that renders HTML and the browser Chrome, the UI. And so the 2 columns represent that distinction. The stuff on the right side, the render, is just stuff involved in loading web pages. The stuff on the left is basically everything else. So in all browsers, you would type in a URL and hit enter. It would send a message to the part that renders HTML. It would then communicate back to the browser, which handles the network, and ask the browser to download the web page. Mostly this would be function calls. You could imagine each of these arrows represents a function call from one section of code to another. In Chrome, it's a bit more complicated because you can't make a function call directly from one process to another. Instead, we send messages between the 2 processes. So every time you'd want to every time the browser wants the renderer to do something, it'll send a message across the process, and the renderer will then do some stuff, and it'll send a message back to the browser, and it'll ask the browser to do something. For technical reasons, the renderer can't actually draw things to the screen because it doesn't have any UI. The renderer, all it does is it takes HTML and it turns it into something to be displayed. The actual display process happens by the browser process. So the renderer can't just paint the results to the screen. It has to just compute what the page looks like, and it sends it back via a message to the browser, and then the browser process displays it to the screen. This communication between the browser and the renderer, we call it IPC. It's an inter-process communication. And it's done by well-defined messages. So we define the messages that the browser can send to the renderer, and we define the messages that the renderer can send to the browser. Each of these lines represents an IPC message. Each of these lines represents a message that the browser is sending to the renderer, or the renderer is sending to the browser. The browser can at any time send a message to the renderer that says, load this URL. The renderer can at any time send a message back to the browser that says, okay, to render this page, I need this image. Can you please download it for me? And so forth. And so each of these lines represents one of these predefined messages. These messages are important because in addition to the benefit of surviving crashes, running in a separate process lets us sandbox processes. What that means is we can get a little bit of extra security by restricting the privileges. Actually, we'll leave that full screen. By restricting the privileges of the renderer processes. So the renderer process, which takes HTML and turns it into something to be displayed, it doesn't need disk access. It doesn't need direct network access. It doesn't need direct clipboard access. It doesn't need a lot of things. And so we restrict it and don't allow it any of these things. The idea being that if something goes wrong, and suppose there's a bug in the rendering of the HTML, we don't want this rogue process to be able to then, say, install malware on your system. To install malware, the process would need to be able to write to disk. And by restricting disk access, it prevents some malware from being installed. The technical details of how this is done is beyond the scope of this talk. It varies from platform to platform. But on Linux, Mac, and Windows, these are the restrictions provided by the Sandbox. Basic things, which used to just be function calls, very complicated. Well, it makes them more complicated. For example, normally writing something to your clipboard is not that complicated. Basically, the browser calls a function in the renderer, and WebKit will calculate what goes into the clipboard, and it'll just write it to the clipboard itself. And it's pretty straightforward. In Chrome's case, it's not that simple because the renderer doesn't have access to your clipboard. So instead, it has to ask the browser to write it to the clipboard for it. So we have a message that basically, from the browser to the renderer, that says, hey, the user pressed Control-C. The renderer then's like, okay, I think this should go into the clipboard. And then it sends a message back to the browser. And then the browser is then like, okay, I will write that to the clipboard. It gets really complicated for some cases. Clipboard is relatively simple in that it's just one extra message. In seemingly simple things like file upload, it becomes much more complicated. Since the renderer can't read a file from the disk, if you want to, say, upload a file to a web page, it involves lots of messages back and forth between the browser and renderer just to be able to do so. In a lot of cases, things that are very simple to do in a single process case become much more complicated. Yeah. What type of security benefit does this give us? If you look at the history of browser security updates, they're very frequent. Like Chrome, for example, I think we push a new version maybe every 2 to 4 weeks because there's a new security bug found. And all browser vendors do this, right? Like Firefox pushes a new version, I don't know, maybe once a month or so because there's a security vulnerability found all the time. Internet Explorer, it's notoriously bad, and it tends to get lots of security updates as well. So we think it's almost an impossible problem, right? It's impossible to think that we can write an HTML render that has 0 bugs and is not exploitable at all. So the assumption is that you're going to get exploited. There is some bug lingering in your code, and somebody will be able to hijack your HTML, your renderer process. Oftentimes, the code's not even in the browser code or the rendering code directly. There have been lots of bugs in zlib, libpng, libxml, common libraries used by lots of applications, and you find a good bug in there, and you can take control of a browser. So the assumption is that somebody is going to find a bug, and somebody is going to take control of your renderer process. The sandbox helps by limiting what the renderer can do to messages that the renderer can send back to the browser. So the renderer can't directly write a file to disk, but it can send messages back like show the file picker. It can send messages back like sending network data. Any of the arrows that go from the renderer process to the browser process, it can still do that. And the assumption is that if you make that surface area small enough, if you make the interface between the renderer and browser small enough, that it'll mitigate the type of attacks that people can do. It makes it hard, for example, to install malware on your system. Although you can still do other evil things like make network requests, because the renderer still has to be able to ask the browser to download pages, and so it can still do that. It can do things like getting your cookies. It can still ask the browser process for your passwords if you use a password manager, and it can still get your clipboard content. But that's at least an order of magnitude better than installing malware on your system. So it's not perfect, but it's better than not having the sandbox there to help you. You can think of it as kind of like a whitelist approach. The browser lets the renderer do certain things, and the renderer can do any of those things as much as it wants, but you try to just limit that to as small an area as possible. This is an example of being able to get file sizes. So you could imagine if you could get file sizes, you could do attacks such as determining whether the user has certain software installed, right? So it would be a privacy leak if a renderer were able to determine, or if some arbitrary web page were able to determine what software you had installed on your computer. So that would be bad. On the other hand, sometimes the renderer needs this information. So like, if I want to upload a file, and I pick a file, the renderer is able to ask, what's the file size of the file that the user just attached to be uploaded? And so in this case, it knows the file is 131K. So the renderer is able to ask questions to the browser, hey, what is the file size of file X? So it seems like with that, you could arbitrarily iterate over the whole browser's computer and determine, well, so tell me for every single file, does it exist and how big is it? So that would be bad. We prevent this by having a whitelist. So there does exist an IPC message. There exists a message from the renderer to the browser where the renderer says, give me the file size of this file. However, that in itself would be a problem. To prevent that from being able to ask the size of arbitrary files, we have the browser whitelist the file. So when the file picker is shown, and choosing a file, we then whitelist that file in the browser process. So the browser process says, okay, the user picked this file, muni.png, and then it adds it to a whitelist that says, okay, if the renderer asks for file sizes, we only give them file sizes if it's on this list. And since the user specifically picked muni.png, it's okay to tell the size of that because the user is trying to upload it or do something with it. It's not some arbitrary file that some web page wants. It's something that the user chose. And by doing that, there we go. By having this extra whitelist step, it makes it safe to have this message between the render and the browser. So we try to carefully audit the messages that the renderer can send to the browser because you don't want to accidentally expose some message that would allow the attacker to install malware. Questions at this point? All right. We're actually super concerned about this, that we go to great lengths to make sure dangerous things don't happen in the browser process. Chrome 3, which was launched a few weeks ago, includes the ability to install themes. So for example, I have this like flowery theme installed instead of the traditional blue look of Chrome. As I mentioned earlier, traditionally things like libpng, which decodes images, has had bugs and has resulted in browser exploits. So to install a theme has a bunch of graphics that come with it. You need to then take the PNGs and decode them. This is dangerous, and so we intentionally don't do this in the browser process. Rather than even unzipping an extension, I think our extensions are just zip files. There could be a bug in decompressing, in unzipping something that could lead to bad things happening. And so rather than trust this to happen in the browser process, which doesn't have a sandbox, we created a new process type. We call it a utility process. And we do all the dangerous stuff in the utility process. The utility process is sandboxed in the same way that the renderer process is, and it doesn't have access to disk. It doesn't have clipboard access. It doesn't have network access. Instead, we define a very clean interface where all the utility process can do is send back images that are known to be safe. So when you download an extension, we actually pass the zip file to the utility process. We sandbox the utility process. Then the utility process will do the dangerous work of unzipping it, decoding the PNGs, making a safe format, and then sending it back to the browser process, at which point the browser's like, okay, the utility process didn't crash, didn't do anything crazy. It sent me images that are known to be safe, and we can now install the theme and display it to the user. So we're starting to use this spin up extra processes when you need security for more cases than just the rendering web pages. And so if you're interested in learning more about Chrome, there's information on how to download it or get involved in the development process. As mentioned, We do have a Linux and Mac version that are in development. Chrome actually has 3 versions. We have a stable channel, which is what most people run on Windows. We have a beta channel, which is pretty much what it sounds like. It's a slightly earlier version of the upcoming release. And then we have a dev channel version. The dev channel version is basically every week we push a new version. It's not tested. It's not guaranteed to even work. It's people who really want to be on the bleeding edge of development. The dev channel version exists on both Mac and Linux right now. And if you want to download and install it, you can try it. They're pretty stable these days. We're getting really close to having a beta release of Mac and Linux version. If you search for Google Chrome dev channel, there should be an easy to install download link to talk about, or to try it out yourself. And if you're actually interested in getting involved in the project, we have an open bug tracker. The source code is available in a BSD-like license. You can pretty much do whatever you want with it. And we all hang out on IRC. We have lots of contributors from other places as well. At this point, question? Yes.
I noticed when you were demonstrating.
I mean, it's using a lot of power for the animation. Part of it's that this computer is really slow and old. This is kind of like a netbook. So 30% is actually more than you would probably see on your laptop if you ran the same animation. But yeah, you should try it and see how much it uses. Part of it is that it was doing a 3D animation, right? And it was doing shading and stuff like that. It's not hardware accelerated. It's all done in software. So it can't take advantage of your graphics card to do simple things like spinning cubes, which is unfortunate. But yes.
Yeah,
Shared memory. In the case of rendering web pages, we actually use shared memory. And so it's just passing a handle back. But it does actually make the rendering pipeline one step deeper because you have that extra copy to memory and then from memory to the screen. We do a lot to make that faster, but it does add a small amount of overhead. Oh. Yeah.
do you have any
Configuration?
yeah, like
Oh, I see. So there are a few. If you look in the task manager, there's a link, Stats for Nerds. And it's probably hard to read this. But it actually shows more details about the process they're running. Like, for example, it tells you the PID. There are actually a lot more processes on the Linux version. Like there's a Zygote and there's a Sandbox helper, which don't exist on the Windows and Mac version. Anyway, and it'll show you some more detail about the memory usage than you find in the regular About menu. There are some other About menus, like About histograms. Oh, maybe that hung my browser process. Oh, there it goes. Hey. Actually, let's start with the simpler one. There's About cache. Be an About cache. There we go. And for example, if you want to see like what files your browser cached locally, You can click on any of these files, like this, and you can see like the HTTP headers that went through, and all sorts of details about what's in the browser cache. About histograms, this is actually mostly for developers, but we track a bunch of stats in the browser, and we make it an opt-in process if you want to share these stats with us. And so, like, this is recording how long it took to make a query on the history database. This is recording how long it took to create a bookmark on your browser. This is how long it took to load the bookmarks file off of disk. And we keep a bunch of these stats because we're trying to figure out where the browser is slow so we can optimize and stuff like that. That's all I can think of off the top of my head. There are some others. If you use your favorite search engine and look for Chrome about : you'll find web pages that document some of this stuff. Yes.
Did you guys imagine that the developer community would extend Chrome with different processes, or do you imagine most people would just play in the sandbox?
Oh, that's an interesting question. So far, other people have not extended the existing processes, process types. Most people, at least for the renderer process, most people see that as a benefit and want to keep the sandbox for that case. I don't think we've seen any forks that involve new process types. Yeah, mostly people are just adding new browser features into the Chrome because we have very few, and often people want more stuff.
So just as a follow-up, you had one nice example of, hey, I want to push this out to a different process because I'm using code I didn't write. It might be buggy. I just want to box it in.
Yeah.
Do you guys have a list on a whiteboard somewhere of other things you guys are considering boxing into different processes?
Yeah, we have talked about that. For example, we use SQLite a lot. SQLite is a nice embeddable database. And we use it, for example, for your history. Your history is stored in a SQLite database. We have seen cases where the database gets corrupt, like maybe the user lost power on their computer while Chrome was running, and the database is corrupt. And when you try to start the browser, for whatever reason, SQLite crashes. All this runs in the browser process, and your whole browser crashes. And so there's been talk about, well, maybe we could run your history in a separate process. And so SQLite runs in a separate process, and if it goes bad, well, that's okay. You lose your history, but at least your browser doesn't go down. We've talked about it for network. All the networking currently happens unsandboxed in the browser process. There are some tricky parts in like parsing HTTP headers that if you get wrong, bad things can happen. And so we've talked about maybe pushing that off. It makes the code much more complicated every time you add another process, and it adds a little bit of latency when you communicate over the processes. So all of these have a trade-off for development as to mainly complexity. And so it'd be nice to avoid that if possible. But we've talked about it, yeah. Some random statistics. We open sourced the project on September 2nd. Since then, we've had 23,000 commits into our tree, which is a lot. Our current commit rate in the last 30 days is 82 commits a day. So the tree moves very, very fast. In the last 30 days, a lot of files have changed. Like I said, it's an open source project. There is at least one fork I know of that's actively maintained, but it's a lot of work. Trying to maintain a fork is going to be a lot of work because we move so fast, especially if you want to keep up with security fixes. Yeah. Some other random stats. It's a lot of code. And so we try to keep as much of it in sandbox processes as possible because the code we write has bugs too. But yeah, it's big. Other questions? He's going to the back. Yes. I used this thing called S5. It's an old. It was made by this guy a few years ago, but it's yeah. If you look at the code for my presentation, it's actually not that complicated. Presentation, it's just a bunch of divs. Yeah, it's just HTML. Yeah. If you search for S5, you can find it. The spinning 3D cube was made by my friend Dean. He wrote a library for doing 3D in JavaScript. And so spinning cubes and stuff are pretty straightforward. I used SVG for the graphics. And I used WebKit. WebKit comes with these fancy CSS transitions. So things like this animation is all like one line of JavaScript. You know, the web is a new platform. That's what they keep telling me. So I'm trying to use it as the platform for presentations. Other questions?
So with each of these extra processes that are spawned by the browser process, your utility process and your renderer process and all that, what is the effect that that has on processor usage and memory usage, and especially when you're running with older machines or lower-end machines that have very limited resources, like, for example, a netbook?
Yeah, so this is based, whoops. This is effectively a netbook. It has like 1 gig of memory, and it has like a 1.2 gigahertz processor. In general, it uses, memory usage varies. It depends on like what sites you happen to be on. And we try to share memory, if possible, among the renderer processes. You could imagine, though, that all other things equal, it might use a little bit more memory. But I think you get the benefits for when you close a tab. You get all that memory back. Like, normally applications can't actually give memory back to the operating system. It frees it for it to use again in the future, but normally it's still allocated to the process that originally had it. And so the bigger benefits are for long-running pages where you close them and reopen new content in its place. Process-wise, it's probably about the same. I don't think there's a significant hit from starting a process. Starting a process is cheap. It doesn't require that much extra effort. I can give a cute story. So when we originally launched the Linux version of Chrome, you may have seen this on Reddit or other programming sites. There was one day in which we had this dude's face in the corner of our browser. And there are some funny threads on Reddit as to who is this guy, and there's this funny bug in our bugs database about I expected it to be a close button, but instead I got some dude's face. So the story behind this is a long time ago, when we were just starting out on the Linux version of Chrome, we just grabbed the graphics from the Windows version because we were in a hurry. And so initially our buttons looked like this, which is very Vista style. And we thought some Linux users would take offense to this, that they have these Linux style or these Windows Vista style buttons on their Linux machine. And so we wanted some more Linux-like buttons. But we are not UI designers. So we asked our UI designer, Glenn, who you see pictured here, to make us some new icons. He said, sure, no problem, I'll do that. A few months passed, and we still didn't have new icons, and so we asked again. He's like, yeah, sure, I'll take care of it. We got tired of waiting at one point, and so one of my coworkers, he's like, well, maybe I can force him to make new graphics by sticking his face here. And it worked. in under 24 hours, he made us new graphics, and so the graphics you see now, which are kind of hard to see in my white theme, they match much more closely to the Ubuntu buttons, and that's what he made for us. In fact, the Linux version still has it. If you happen to start Chrome with the Glen command line, you will still, in fact, get Glen's head for the close button. And hopefully, by telling that story, I will not have caused that feature to get pulled back. Anyway, other questions?
Do you expect your process security model to be like also incorporated in Google Chrome OS, or?
I'm probably not allowed to say anything about Chrome OS. I work with some of the guys. They're still working on it. Some of the code is actually in the tree. We are an open source project, so there is Chrome OS specific code for Chrome in the repository. But yeah, I'm probably not supposed to say much more about it. Sorry. I can share some more stories, or we can call it quits. These are not as humorous tales, but we tend to get very frustrated. We've been dealing with this recently. We get very frustrated with UI that prevents you from doing what you want. One of the benefits by putting the renders in a separate process is if JavaScript goes bad, for some reason the user wrote like a while loop in their JavaScript. In other browsers, this tends to block your whole browser, and so even though one tab happens to have like a bad while loop or whatever, an infinite loop, in Chrome we wanted to make sure you could still interact with the other tabs. So there's like about hang, and I think this just starts an infinite loop. Maybe not. Oh yeah, it did. So when I click on things, nothing happens. But we still wanted to make it so you can interact with these other pages. However, we have this unfortunate case where you can trigger an infinite loop in the unload handler of a page. And so as I try to navigate away from this page, or let's say close it, I can't. Because now it's caught in an infinite loop, and it's in the unload handler, and the tab is not allowed to close until JavaScript says it's allowed to. I can still interact with other pages, and so it doesn't completely hose my browsing experience, but it's kind of unfortunate that I can't actually close this tab. And it's really frustrating to the user, because they're like, I'm hitting the X, why isn't it going away? So we talked about possibilities and what we could do with in cases like this. We talked about maybe you could hide the tab, and then wait for it to close, and maybe it won't close, but who cares because the user doesn't see it. So at least when you hit the X, it went away. But that doesn't actually work. You can't do that. Let me kill that process. That doesn't actually work because when you close the tab, if we made the tab disappear immediately, we can't do these. This is the on before unload handler of JavaScript. So JavaScript has this ability to ask you, well, do you really want to navigate away from the page? And if we made the tab disappear and then this dialog appeared, it would be very confusing as to where did this dialog come from. And so we're kind of in this conundrum that like the user wants to close a tab, but the web page doesn't want to close, or maybe it's just buggy and there's an infinite loop. And what do we do? We actually don't have good solutions for this. But these are the type of problems that in designing a web browser. You want to maintain web compatibility. You want to still support things like on before unload and on unload. But the cost is your user experience might not be what you want. Anyway. I'm running out of stories. Oh, question.
I was just wondering if you guys did any like process priority scheduling based on active.
On Windows we tried this initially. I think during the whole Chrome 2 time frame, what we did was in Windows you can say like this is a background process or this is an active process. And so we tried making it so that the tab that's in front is the active process, and all your other tabs are considered background. And so you like set a flag in Windows that says this is a background process. We tried that for a while, but in practice it didn't work out that well. The problem is when Windows thinks it's a background process, it tends to when you need more memory, it tends to push that whole process into your swap, into your virtual memory. And then, so what happens is when you try to switch back to that tab, there's like this 5-10 second lag while Windows is swapping everything back into memory so that it can show the tab. So we tried it for a while, but in practice, it ends up causing more swapping and more page faults, and so we kind of gave up on that. This is actually still a problem on Windows. It's quite common that if you suspend your laptop and you have a lot of tabs, when you bring your laptop out of suspend, Chrome takes longer to be usable than other browsers because it has to page in all the different processes, and it's not like one continuous chunk of memory that it can just pull back in. Yeah, we're throwing around ideas and ways to make that better. So extensions, if you download a dev build of Chrome, extensions are enabled. And so there's work in the process of having extensions. The extensions have been designed such that they're just web pages. In fact, I can probably install one. Chrome extension Gmail. Simple extensions. The UI has not been finalized. This is only on the dev channel. So this little thing down here in the lower left corner is an extension. And it checks my Gmail and it tells me how many messages I have. This little rectangular space is just another renderer process. It's literally just an HTML page with some extra JavaScript callbacks, so you can do some extra things. But it's just a web page. So in some sense, it makes extensions easier. If you want an extension, it's just HTML. And we already have this infrastructure, and there's a sandbox and stuff like that. And that's all used for these extensions as well. On the other hand, there are some limitations in how much you can do. You can only do as much as a web page. But yeah, that's the direction we're moving right now. Bluetooth, what do you mean? So I feel like that's something handled by the OS, right? Like Chrome doesn't manage your Wi-Fi connection. I think for the browser itself, we plan to keep things like managing your connection. We'll leave that to the operating system. Yeah. I think that's great, actually. But okay, sure.
two buttons on the side look for managing your settings. And now Safari did that with its new version for Windows, and Firefox says, hey, that's cool too. So how do you think that's impacted, the culture of software development? And do you think that this is something that's going to keep going? And do you feel bad when you do it?
No, I think it's great. From a user standpoint, it's good in that your browsing experience is more unified across browsers. I think it's more like competition, right? Like in the Linux world, there's GNOME and KDE, and they both implement something very similar, and they share a lot of features. But it's good in the sense that they motivate each other to do better. And I feel it's the same way, that it's constantly forcing browser manufacturers to come up with better ways to do things. And, I think it's okay that all the browsers tend to borrow features from each other. Tabs, for example. Tabs are such a great invention. It would be a shame if only one browser supported tabs. I think it's progress that these days every browser supports tabs. I don't know. It's like a good thing. There are no other questions. That's all I have. Oh.
Thank you. So with your separated process between your rendering and your display, how is that going to impact implementing something like a WebGL?
Yes. So WebGL, if you're not familiar, there's a spec for doing 3D type things in the browser natively. I showed a 3D spinning cube, but that's all software rendering, and it's all basically you're doing all the hard stuff on your computer rather than on your graphics card. WebGL makes it possible so that you can do fancy 3D stuff on your graphics card, like it should be done. It is tricky. I have no idea how they're going to make that work. Yeah, in the existing implementations, I think Firefox nightlies have some support, and Safari nightlies have some support for it. They have the renderer talk directly to the graphics card to do this kind of stuff. Yeah, I'm not sure how that's possibly going to work. Question. Somebody landed some preliminary code for Windows to do WebGL. Currently, you have to disable the Sandbox to do it. So you have to allow the renderer process access to your video card. I'm not sure what the plan going forward is, but I think the guy working on it, he has some plan, or he wouldn't have started working on it. Maybe there will be a design doc floated at some point. That's all I have. Thank you.